this is a 2100 light conservation of angular momentum. So let's go theory first, and we're going to verify conservation momentum use instruments like this. Okay, let's go over the theory first. And then we know Newton's second law, F equal to ma. So net external force equal to mass times acceleration. We can write down in this way, dv dt. I move the m inside. When net force equals 0, m times v have the constant. This is a vector, okay? So by the same theory, so we would talk about torque. Torque equal to dl dt. L is angular momentum, and this mv is linear momentum. So when a net internal torque equals 0, and then this angular momentum will become constant, conserved. So by your lecture, you know angular momentum equal to I omega. Moment inertia is angular speed. Angular velocity. So, and then today we're going to just verify when torque is 0, and then this angular momentum is conserved. Okay, so initial and final. So we go here. So we're going testing this equation if it is established or it is right. So, and then it's right, then momentum, when there's no external torque, will be conserved. Okay, we're going to find this equation, left side and right side, and calculate, and if they're equal, okay? So, and omega I, omega f, we're going to get from software. I will show you later on. And then the problem is we have to find the moment inertia initial and moment inertia final. So we're going to use these instruments, and later on in the lab room, I want to show you. And then there is there's a two mass, sliding mass on this vertical shaft. So when they're like a ice skater, the opening is this we call the final stage. When the ice skater close the arm to the chest, we call initial position. So you know that when the ice skater, when they close the arm to the chest, they will spin faster, right? So because they reduced moment inertia, and then the this is initial. So when they put the arm to the chest, actually they reduce the moment inertia, and then that's why they spin faster. Okay, and right now our job is to find the moment inertia. After we find moment inertia, we plug into here and see the equation is equal or not. Okay, so we will set up something like those. I will hang a mat through the pulley, and then there's wax. So, and there's some wax. I'm going to wrap around the rings around 8 times around this vertical shaft, and then let the mass slide down. Through this setup, we're going to find and the moment inertia. Okay, so this torque. This is not this torque. So you know the torque equal to I omega. So torque also equal to Fd sine theta. There's two definitions of torque, but they're talking about they calculate same torque. So I hear F is the tension, because the tension make this machine spinning. So the force is the tension. So D is the distance from applied force to axis rotation is the R. And in the radius of this vertical shaft. So it's R, and the angle is between R and T is 90 degrees. So it's sine 90 equal 1. So this is equation 1, this is equation 2. Since they calculate same torque, so they're equal. So this one and this one equal. And then our job is to find the moment inertia. So moment inertia equal to TR divided by alpha. I'm sorry, this is alpha, okay? Omega, this is omega. And then if we have to find the T, plug in, and then we can find the moment inertia. So we come back here, you see in this diagram. So we will set up this is tension, this mg, the was sliding down, and then mg minus t equal to ma. So when there's rolling, this string and rolling down without sleep, so this a will equal to alpha times r. And then I plug in everything, I got a tension equal to this much. I know it's a lot of math today. So, and then I plug the tension to here. And then this is the equation we're going to find the moment inertia. So this mass, m, is this mass, higher mass here. G, you can use 9.8 meter per second squared, or you can use 980 centimeter per second squared, depend on you measure the r, use centimeter or meter, okay? So make a consistency. So this angular acceleration we're going to get from software. So you plug everything in, you find I. So I initial is they push two of the mass to the center. This is initial stage. And then when they open it up, the slide far side, this part is the final stage. So and then we're going to let the computer find alpha plug in.